Hello my dear students, this is Akash SD and welcome to the ASG Physics classes. I hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Thermodynamics, and here we are going to see the first law of thermodynamics in this question. Okay, so let's go through the question and let's all learn this. A total of 48 joule heat is given to 1 mole of the helium kept in a cylinder. The temperature of helium increases by 2 degrees Celsius. The work done by the gas is how much here, and all these things are given. Okay, so first we'll note down here the data. So first they are telling here how much here, 48 joule heat. So here heat we can write here this Q, or you can write delta Q also, no problem. Delta Q they have given here 48 joule heat is added, given to the system. When heat is added to the system, positive. Heat is removed from the system, negative. So remember that here this is the positive. Okay, after that what they are telling that here the temperature of the helium gas increases by 2 degrees Celsius. Okay, so here you can write here this delta T is given by 2 degrees Celsius, and you know very well, even on a degree Celsius scale or in a Kelvin scale, the number of divisions are same handed only. So only the change in temperature on degree Celsius and Kelvin scale will be same. Remember that here. And how many moles of helium is there? 1 mole of helium is there. That means mu is given here 1. And one more hint is given here, helium. Helium is the which gas? Helium is the monoatomic gas. Okay, and for the monoatomic gas, remember that here the CV value here, the molar heat capacity at constant volume, this is given by the 3R by 2. Monoatomic 3R by 2, diatomic 5R by 2. Okay, so all this data is given here, and we have to calculate here the work done. So students, remember that here from the first law of thermodynamics. Which law? First law of thermodynamics tells that, what it tells? Delta Q equal to delta U plus W. Delta W also you can write, no problem. Okay, so in this situation what will happen that here? This W is given by delta Q minus delta U, is it? And delta Q, let me write here as it is, we have to simplify this. Delta U, remember that here delta U is always given by mu CV delta T. Okay, mu CV delta T, and after that kindly say this delta Q minus mu CV, what I have told you, 3R by 2 into delta T. Okay, this is the work done formula. No? So this thing you have to remember that here. This thing you have to remember that. Is it? Now after that students, we will just put here the values and all that. Is it? So see, this work done is given by how much is there? How much heat is added? 48. 48 is there. No? 48 joule. Joule. This thing also should be in a joule only. Okay. Mu value how much is given here? 1 into 3R by 2. So 3R by 2 into delta T. Delta T how much given here? 2 Kelvin. And remember that here, see, joule Kelvin inverse mole inverse. So when you will do this R delta T, the moment you will put the value of R, that means this Kelvin inverse will be cancelled by this delta T, this mole inverse will be cancelled by this mu, and what will be left? Joule will be left. That means here this side and that side it will match. Remember that here, otherwise it will go wrong. Units are very, very important. Okay, so this 2 and 2 is cancelled. That means both joules we are subtracting. Remember that here. Okay, so this is coming here 48 minus 3 into, what is the value of the R here? See, 8.3. 8.3. That means 48 minus 3 3 is 9 and 3 8 is 24. Is it? So 48 minus 24.9 something 0.1 will come. Okay, so when you will simplify this, it will come here 23.1 joule. That means students, you can see very well the correct option is here. Option D is the answer. Okay, can you see very well how we have done this? Is it? So students, I hope so this video you have understood very well. Keep studying, keep growing.